Hello and welcome to another video. This is Cracking the Cryptic app, Fog of War pack, puzzle number 9. Circles in a box. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Killer. The cells in each cage must sum up to the number in the top left corner of the cage, and numbers cannot be repeated inside a cage. Arrow. The numbers along the shaft of each arrow must sum to the number at the base. Without further ado, let's begin. We are given circles in a box, very fitting. And the question that immediately presents itself is, where does the number 1 go inside this box? Obviously, the number cannot be here in the center, because then we see that this is a part of the shaft, and that will mean that this number is a number other than 1. It would be a number higher than 1. And that already ruins the equality, because there is no way that the numbers along the shaft of the arrow could sum up to the number at the base, because the number at the base is smaller than what a cell in the shaft contains. So this cannot be a 1. What about any of these squares? Can any of these be a 1? Well, first we make an observation, and that is that none of these shafts are diagonal. The direction of the shaft is always sharing either the row or the column that the base is in. And that means that you cannot repeat numbers in an arrow, at least initially. So if this is a number 1, this down here cannot be a 1. And that's true for all of these situations. So that means that the first number in the shaft of each of these 7 arrows is always going to be a number greater than 1 if you have a 1 at the base. So if there's a 1 here, the number just below it, because it's in the same column, would have to be 2 or higher. And that already ruins the inequality. And that's true of all of these scenarios for the exact same reason, because the direction that the shaft is taking shares either the row or column with the base of the arrow. And that's why the number 1 cannot show up anywhere there, meaning that the only possible place we have left is over here, and that's our number 1. So first, let's select all the other possible places where any other digit could be, and let's all fill them in to make it a bit easier for us. 1, 2, 3, 4, 5, 6, 7, 8, 8 and 9. Oops, 8, 9. And that's the number 1. So now a 7 cage revealed itself to us, and we see that it is at least 3 squares long, and we know that it cannot be 4 squares long, because that would mean that the lowest value of it could be 1, 2, 3, 4, and the sum of those numbers is already higher than 7, so it must be exactly 3 cells long. And the only way you can do that is with numbers 1, 2, and 4. So let me just put this here. Yep, it's numbers 1, 2, and 4, meaning that 3, 5, 6, 7, 8, and 9 aren't here. And since the number 1 must be inside the cage, that must mean that it's over here. Now, this reveals some new stuff to us. We have a 6 cage, which is 2 cells long, meaning it's either 2, 4 or a 5, 1. So there's no 3 here, 6, 7, 8, or a 9 there. But look at this, we have a 2, 4 pair. That must mean that 2 or a 4 is nowhere there. So 2 and 4 can't be there, meaning that this is a 5. So 5 and 1 must be making the 6 square, the 6 gauge, and since we have a 1 and 1 along the shafts, that must mean that the base is 2. Alright, so number 3 cannot be here, because if 3 is here, then this would be a 6 as the lowest value, which is already higher than 3. So this cannot be a 3. This number over here cannot be a 3 or a 4 because 3 and 2 are the lowest values along the shaft, which is already 5. Oops, so this cannot be, my bad, this cannot be a 3 or a 4. And same is true here, 3 and 2, so this cannot be a 3 or a 4. All right. So we see that we have a 14, which is, oops, 14, which is exactly 2 squares long, making that 5, 6, 8, 9 as possible values. So it cannot be a 2, 3, 4, or a 7. 5, 6, 8, 9 are the possible values. And now, let's do the same for the 15 gauge. So the 15 is either 6, 7, 8, or a 9. 2, 3, 4, and cannot contain a 5. 6, 7, 8, 9. Well, immediately we see that this cannot be 6, 8 for the 14, because if it was, the 6 and 8 would be here, meaning that the 6 isn't here and the 8 isn't here, so no combination could make a 15. So this cannot be a 6, 8. So that's a 5, 9. So a 5, 9 cannot be anywhere here. 5 and 9 cannot be there. And furthermore, that must mean that this thing over here is a 7, 8. So 6 cannot be here. So that's a 7, 8 pair. 7 and 8 aren't here. Now, since we do see that this sums up to 6, plus 1 is 7, then this is the 7. And what about this? Can this be a 5? No, because this is the shaft. It goes like this. And that would be way too small because the least value here is a 7. So this has to be the 9. And since we have a 2 over here, that must mean that this cannot be an 8. This must be the 7. 2. So this is a 5. And then this is the 8. Now, can this value here be a 6? Well, let's see. If that's a 6, then this has to be a 3, because a 6 is taken and 7 is higher and 9 is higher. So that would be a 3. But then the lowest value here would be a 4. And 3 and 4 together are higher than 6. So this cannot be a 6. This must be a 9. All right. So we see that there's some cage over here, but we don't see where it starts. However, since there is no 5 over here, this cannot be a 4. And since there's no 2 over here, this cannot be a 7. So that's a 3, 6. And since that 3 and 6 cannot be anywhere here, that must mean that this is the 7. Okay, so since they sum up to 12, that must mean that this is the 5. And now we see the actual length of this. So this cannot be an 8 because there is no 1 here. So that would be 10 as the minimal value. That's not acceptable. This cannot be a 9 or an 8 because there's no 1 over there. Can it be a 6? Yes, it can. 6, 3 works. 4. Okay, so it cannot be a 4 actually, because 4 plus 6 is 10 and 4 plus 3 is 7, and there's no 7 here, so it cannot be a 4. And I think the rest works. So let's see. Can this thing be the base of an arrow? Obviously, that would not be able to be a 1. And it cannot be a 4 either, because if that's a 4, then that's a 1. That's 2. And 1 and 2 is already 3. And since this is like 3 cells long, there's no way you can make a 4 3 cells long. So that this cannot be the base of an arrow. It must be a part of the shaft. So 1 and 4 together are 5, plus 2 is 7, meaning that the 7 is the minimal value at the base. So this cannot be a 2, 3. Oh, 1 second though. Can this be, so 1 and 4, that's a 5. Minimal value here is 2, making that a 7, meaning that this cannot be also a part of the shaft. That's what I was checking. I was checking if this can be a part of the shaft as well, but it can't because 7 plus 3 would be too high. Okay, so the minimal, this is the base of the arrow, and the minimal value here is 7, so this cannot be 2, 3, 4, or a 6. That's either a 7 or an 8. And all right, that must mean that this cannot be 8 or a 9 or a 6. It also cannot be a 4 because a 4 and 1 are down here. So let's just clear that. So a 1 and a 4 are down there. What else do we have? So over here, you cannot possibly have an 8. 7, 2, that works. Let's go through the digits, I suppose, and see if we maybe miss something. So 1, 2, and then we don't have a 3 anywhere, or a 4. We have a 5. We don't have any 6s, 7, 8. Okay, so the 8 has to be here. All right. That doesn't really help too much. Does it? No. And then we have a 9. Let's see. Oh, okay, so the 9 is here. That's gonna help. All right, so because the 9 must be over there, we now see the 13, which is 2 cages long. And the way to get it is 4, 5, 6, 7, 8, 9. So this cannot be 1, a 2, or a 3. Cannot be 2 and 3. All right. So since it cannot be a 9, it doesn't have a 5, so it cannot be 5, 8. It cannot have an 8, so that's a 6, 7. So a 6 and a 7 cannot be there. And neither can a 6 be down there. So that must make this an 8. So this must be a 3. Because this sums up to 5. So this is a 2. And then this is 3. 4, 2. 4, 6. 3, 6. And then 2 and 3 sum up to 5. All right, so this cannot be a 9 because it's a shaft. This cannot be a 7 because 7 plus 1 is 8, and there's no 8 here, and 7 plus 3 and higher is way too high. So this cannot be a 7. Now, let's go through the digits again. So this is a 1, all right? 2, 3, 4. This cannot be a 7. No, it can. Never mind, because 7, 2. Right, 4, 5. All right, so the number 5's, no, this is a 3. So the number 3 is either here or here. And that must mean that it cannot be anywhere here. So this cannot be a 3. Let's go again a bit more slowly. So 1, 2, 3, 4, 5, all right. 6, 7, and 8, and a 9. So it's probably... All right, so this thing here cannot be a 3. Because if that was a 3, then the lowest value here would be a 5. And the 5 is greater than 3, so it cannot sum up to 3, so that doesn't work. So this cannot be a 3. And the only other square in this box that can be a 3 is over here. So that is the 3, making this a 2, 1. So this is the 2, and then this is the 1. So since the maximal value here is 8, this cannot be an 8, or the value above it. Neither of them can be an 8. And since there's no 2 here, that also cannot be a 6. Because if it's a 6, then that must mean that this is the 8, and 6, 2 would make the 8, but there's no 2. So that's a 3, 5 pair. So there's no 3 or a 5 up here. And since that's a 3, 5 pair, then that must mean that this is, in fact, the 8. So that's a 6. And then this is the 9. 4, 8, 7 means that this thing over here cannot be a 4, an 8, or a 7. And now since this is the 9, and there's no 2 here, this cannot be a 7. And since there's no 3, this cannot be a 6, so that's a 4, 5. This is a 3, 6, 9 triple, so this cannot be a 3, a 6, or a 9. And since that's a 1, 7, 8 triple, you cannot have a 7 or an 8 or a 1 up here. And that gives you a 3, 5, 9 triple, so a 3, a 5, or a 9 cannot be up there. Since this is a part of a shaft, this cannot be a 9. And now we only have these two left from the center. Can this... Well, since this is a part of a shaft, this cannot be a 9. It also cannot be a 7 because the maximum value is 6 in the base. And it cannot be a 6 for the same reason. And same is true here. This cannot be a 6 because it exceeds the max value of the base. So can this value be a 4? Nope. Because 4 and 3 exceeds the maximal value. And can it be a 3? 3 plus... So this value cannot be a 6. Because a value here, 6, exceeds the max value of the base. 6 plus 1 would already make it too high. So this cannot be a 6. Therefore, this is a 3. That's a 1. That's a 4. And that's a 4, 2, and we have a 6 here. So that's a 9. So this is a 9. And then we have 8, 6, 7, 3, 1, 6, and then this is 2, 8, 9, 7, and then this is the 6. So you have 5, 7, All right. And what else? So this is a part of shaft, so it cannot be a 9. Now, what else? I guess we should go through the digits probably. So this is the 1, 2, 3, 4, 5, 6. Okay, and then 7, 8. The 9 is up here. Okay. That makes this a 9. So that makes a 7. It's either 5, 2 or 4, 3. Okay. 5, 2 or 4, 3. Both work. But since that's a 9, this cannot be a 6, because 6 plus 2 over here, which is the max value, would be an 8. So this must be a 7, 2. So that's a 1. This is a 4, making that a 2, 5. That's a 3. So that's a 3. This is 5, 8. That's a 6. 1, 5, 4. Then that's a 6. Oops. That's a 6. So that's an 8, 3. Now here, oops, that's an 8, 3. Oh my god, I selected both of them. So it's not letting me fill it in. So that's a 3. That's a 5, 4, 1. And the puzzle is over. Okay, that was a fun one. Thanks for watching, and see you in the next one.